So we are learning to do transformations and linear transformations in particular. So suppose a given function is fx. So if it moves left by a units, we write it as fx plus a. So remember here we add a to x. Okay. Like if it is fx is suppose x plus 5, and if it is moved to 4 units left, so we write it as x plus 4 plus 5. And right by a units, so if a function moves right by a units, we write it as fx minus a. So this is here is not making any difference because it is a linear function, but this rule will help you in quadratic and polynomials. So we are preparing ourselves with the base that we can do all the problems. So if it moves right by a units, then we write it as fx minus a. So suppose uh, fx is x plus 5. So this would be, and if it moves right by 4, so it would be x minus 4. So wherever there was x, we write it as negative 4 and plus 5. Okay. So here in left and right, we when a function is moved to left and right, we uh, make we add and subtract a to x, not to the function itself. Okay, so like vertical up by a units. If a function moves vertical up by a units, function is fx, then we do fx plus a. So in the left and right transformations, we used to add and subtract a to x. Here we are adding a to the whole function. And if it is vertical down, by a unit, then we subtract a from the whole function. So we are subtracting a from the whole function if it is vertical down by a units. Now, if it is reflection over x-axis, so if this is fx and if it is reflected over x-axis, means suppose this is x-axis and if this is a function fx, if it is reflected over x-axis, the whole function gets negative. So fx transforms to negative x, fx. Same way, if it is reflection over y-axis, then if this is fx and y-axis, so the function in this x is replaced by negative x. For reflection over x-axis, we used to multiply negative to the whole function. Here, only x is replaced. Wherever there is x, it is replaced by negative x. Then we can take a vertical stretch and shrink. So suppose there is a function fx, and uh, if it is if it is stretched vertically by a factor of a, then we just multiply it by the whole function is multiplied to a. If a is greater than 1, then it is vertical stretch. If a is less than 1, then it is vertical shrink. As we can see, if this is the fx and suppose a is 2, so it is 2fx. So all values are doubled here. So it will be like this. This is 2fx. So it is a vertical stretch. So here a is greater than 1 and that is 2. Now half fx. So all the values are of fx are halved. So it will be like this, half fx. So because a is less than 1, so it is a vertical shrink by a factor of half. Okay. So in both the cases, we simply multiply the whole function by a. Now we'll look at the horizontal stretch and shrink. So horizontal stretch so suppose this is a function fx, and so if it is stretch or shrink by a factor of a, we divide it by a. So suppose a is equal to 2, so horizontal stretch by factor of 2, so it will be fx would be now fx by 2. And in the horizontal stretch or shrink, we only divide x by 2 or x by a. Whereas in vertical, we used to multiply the whole function by a. So this, if there is a vertical shrink by a factor of 2, Oh, sorry, horizontal shrink. Horizontal shrink by factor of half. Then fx would become f of 2x. Okay. So x is replaced by 2x. Only x is replaced. Whereas in vertical, we used to multiply the whole function fx. Now we have to also take care of the sequence. And the other thing we have to take care is when we move a function to left and right, we only move x, we only replace x. Suppose a function like is given fx 2x plus 1, okay, and we are given like it is reflected over y-axis followed by left followed by left shift by 3 units. So what we do is reflected over y-axis means x is moved to negative. This is f of negative x, okay, plus 1. So it is negative 2x plus 1. Suppose this is C. So reflected over y-axis means only x is uh, made as negative x. Okay, now this is our new function, and then left shift by 3 units. So left shift by 3 units means x is made x plus 3. Wherever there is x, we put it x plus 3. So we factor out whatever is with x. Like this is minus 2, okay? And then x is moved to x plus 3. Not like negative 2 and x plus 3, not the whole thing. So wherever there is x, it is moved to x plus 3. So first we factor out negative 2. First we take out negative 2. And instead of x, now we write x plus 3. So it is reflected over y-axis. So x is made negative x. We simplify. And then followed by left shift by 3 units. So x plus 3. So and 1 is as it is. Wherever there was x, we made it. So now we'll suppose f of x, 2x plus 1 is given. And with this, the transformation we have to do is like right shift by 4 units followed by vertical shrink by a factor of half. We can say by a factor of 1 by 3. So what do we do is right shift by 4 units. So this is Wherever x was there, we'll replace it by x negative 4, x minus 4. So 2, we do it only to x. We don't do it to 2x minus 4. We just do to x minus 4. Wherever there was x, we replace it by x minus 4 plus 1. So this is g of x. Okay. And the g, and now vertical shrink by factor of 1 by 3. So we multiply the whole function by, because it is a vertical shrink. So whole function by 1 by 3. So this would be 1 by 3 to x minus 4 plus 1. Okay. We can take another problems also. Like translation 3 units right and translation 1 unit down. So f of x is given as 2x minus 1, and it is translation 3 units right and 1 unit down. So 3 units right would be x minus 3. So this will be 2x minus 3. We'll just replace x with x minus 3, negative 1. Okay. And suppose this we'll put it as g of x and 1 unit down. So whatever the function was, we do it negative 1. So this will be 2x minus 3. In this 3 units right, we replace x with x minus 3. And 1 unit down. So it was already negative 1 and now negative 1. So this will give us 2x minus 8. Now the next is, again fx is 2x minus 1. Okay. And it is translation 1 unit left followed by reflection in x-axis. So it is translation 1 unit left by and followed by, so it is very necessary that we do it steps wise, like 1 unit left and then get the function and then followed by reflection in x-axis. Reflection in x-axis. So 1 unit left would be x plus 1. Okay, 1 unit left means we add 1. So 2x plus 1 Wherever there was x, we put it this way. And now suppose this is g of x, reflection in x-axis. In x-axis means we multiply everything by negative. So this will be, the whole function would be negative. So 2x plus 1 negative 1. So this would be negative 2x and this would be 2 minus 1, so 1 negative 1. Okay. Now one more part for this. If f of x is given 2x negative 1, and then the question here is horizontal shrink by factor of 1 by 3 and translation 5 units up. So horizontal shrink by factor of 1 by 3 followed by translation 5 units up. So this will be horizontal shrink means it will be f of x, so 3x. Wherever there is x, we will put 3x. So 2 into 3x minus 1. And this is g of x. And translation 5 units of. So g of x 5 units of means we add 5 to the whole function. So this will give us 6x minus 1 plus 5. So 6x plus 4. We can do one more problem. Is translation 1 unit up followed by, so translation 1 unit up followed by reflection in x-axis and translation 3 units left. So 1 unit up means it will be fx plus 1. Okay, so -1 plus 1. So it will become 2x. Okay, and followed by reflection in x-axis. So this was your gx, suppose. So this is 2x. And reflection in x-axis means minus gx. So minus 2x. Okay, in x-axis means the whole function is multiplied by negative. And translation, 3 units left. So this was suppose kx. So 3 units left means x plus 3. So this will become minus 2, and remember we only do it to x. So it will be x plus 3. Okay. So we have to follow the sequence which is given in the question. Thanks. We'll again do the absolute translation in absolute values in the next class. Thank you.